Hello, myself Vasistov, and I am from RGK2 Ongol, and I am studying in stream of electronics. And today I am here to explain you about what we have learnt in our. I am here to explain you our project, how to program a microcontroller board for automating mission. And primarily, let me explain what we have learned in this program. We have, we have, we have basically C programming. Embedded C programming. That's C programming, where we use it to build embedded systems, and some knowledge about the microcontroller boards and peripheral components like timers, clocks, etc. And regarding our project, we have completed our project like how to automate a washing machine using a microcontroller board. That's our project. And basically what we have learned means we got deep knowledge regarding the C programming and for coding embedded systems, and knowledge regarding the embedded systems, like how they are built and being used. And regarding microcontroller boards, we have learned about how they are being programmed, and their architecture, and how they are used with some peripheral interfaces. Peripheral components like LEDs, timers, switches, etc. And we have, by the end, we have built and completed embedded application, that's our automated washing machine using microcontroller board. And regarding embedded C programming, we have deep knowledge regarding data types, strings, pointers, arrays, etc. And while in data representation, we have got data types and how they are declared and defined, and how they are used. And in strings is nothing but a type of storage where we store characters. And we have learned about operators, arrays, and operators like regarding some mathematical operators, logical operators, and bitwise operators. And we have entirely used arrays is a storage of homogeneous data, where we use to store a common type of data. And in pointers and functions, we have attained some knowledge, and we used it like pointers to store some location of your data. And functions, basically we mostly use functions so that we can recall it and use it many times. And regarding the microcontroller, we have got some basic knowledge regarding microcontroller boards, and deeply we have learned regarding PIC16F877 microcontroller board, where it is from the PIC micro family, and of uses, wide range of uses, because it has easily accessible architecture, and it has wide range of features that we can promote, and we use it mostly because it is our ideal choice, so that we can easily learn control boards. Regarding the features of it, PIC16F877 board, a performance CPU processor unit, and it has wide range to connect use peripheral components, and it has a wide range of analog features. And it has 256 bytes of EPROM, and so that we can much easily and we can F877 board. This is what we use in programming our automated washing machine. It has wide architecture, accessible architecture, and easily understanding board. And regarding the timers, we use timers, certain delay, etc. Certain fixed delay to our microcontroller boards. And timers are nothing but a binary counter that defines the accurate time delay. Regarding our we are here to build a complete embedded system, that is a washing machine that we use in our daily life for washing clothes. And here all the components are embedded using a certain microcontroller board. And here while regarding the hardware components that we need an LCD display, fan, buzzer, switching circuit. Like how we have here where 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 current, when you load nothing but when your load is connected to a device, applies current to the load. I mean, configuration is said to be current sourcing. Regarding the current sinking device, so that current flows from the power supply and load and into the device, then the configuration is said to be current sinking. And in our project we use four different softwares, like MPLabX IDE and XC8 compiler and Pixim Lab and online GDB for C programming, embedded C programming. And while regarding those tools, primarily MPLabX IDE, here we use it to write the code for our embedded system. It is highly configured, and we can easily require stuff for our embedded ecosystem. And it is an IDE, I mean development environment, which is completely free, so we can use it. And actually it is a compiler that we use to flash the data that the code that we write in our IDE to our microcontroller board. And Pixim Lab, which we use, which is mainly important. And here Pixim Lab is used, it is mainly important. It creates an digital environment where we can have the entire hardware stuff, so that we can simulate it online, simulate it virtually. And while coming to online GDB, it is an online online debugger and compiler for C and C++ that we use to code for embedded systems. And finally, by using these four softwares, we are going to complete our project, that is building a washing machine using coding a microcontroller board. And let me explain you how we have built our washing machine, the simulation process. As we have saw what we have learned till now in our internship. Now let me simulate how we can code and simulate our automated process machine in MPLabX. Here we have included our main header files like digital keyboard.h, timer.h and clcd.h. And we have taken fan, buzzer and some of the main things we use. And these all are the cases which we have to implement in the Pixim Lab. Here we take daily heavy delicate whites, side wash, eco cottons, woolens, bedsheets, rinse plus dry and more. And some of the types of cloths, and how we are going to implement. And water level options are auto, low, medium, high and maximum, which have we taken. Here we give rinse time, wash time, spin time also. And here the main thing, if you press key 5, the machine will be on. For this we printed it onto display on LCD. These are all the operation modes which have we given into the embedded system. These are all the some cases where we have given for our embedded system. And these are the pressing key 5, it powers on the washing machine. And these are the block lines that we have given, line 4 and line 1. And this is the time delay, 1000, I mean 1 second. And we then clear the screen, and some more code, I mean process will be implemented. And highlight of the daily washes, I mean washes, sorry, here are the display printing code syntax to washing program. And here we have given a number for everything. In a coding for this we given 0 1 0, heavy 1, delicate 2, whites 3, stain wash 4, echo cottons 5, woolen 6, bedsheet 7, rinse plus dry 8, and dry only, wash only. Like that we have given some of the indexes for the array. And now here we have given the indexes to write the syntax like that. And line in pixel line 2, where it will be implemented in line of 2. Like that we have given our code. Next then we will give our water level mode, water level highlighting we have given. After that we give some cases of washes that we have been, I mean type of clothes, like daily clothes, heavy clothes. And these are the cases, all are the cases which have been given. Here we given seconds and minutes also. These are the cases, water level cases, wash only, and aqua store, we have given same level of water. For next we are writing for status and this code. After that time should be included, and we have given time of 3 seconds, which means 3 milliseconds. For that we given function and time, and 5 for start and 6 for pause. And this is the code for time, total time. After that washing machine will be on, and the timer will be on, displayed on. And 6 is, when 6 is pressed, fan will be off and timer will be stopped and operation mode will be paused. Here we have given some of the conditions: wash, rinse, spin. Wash will be a 42%, rinse will be a 12%, and spin will be a 46%. After that, if you press this switch 0, okay, switch 1, the door will be open and it will be indicate like please close. After closing, it should implement it. Okay, after completion of this, all the program will be, if the door will be open, fan will, after closing, fan will be off. And if after the closing of the door, fan will be on and buzzer will be off. And we are going to see now implementation of code. That code, load a hex file. This is the path for that hex file. This is the hex file that we are loading. Unload it. Now no powering on the washing machine. In this is the Pig Genius board which we have using, and this is a fan buzzer, Pig 16F877A microcontroller which we are using, and this is a reset button, and this is LCD display. Here are the 4 lines of display, 1 2 3 4. These are the line 2 of display, 1 and 2. Okay, now we are going to reset button. Okay, power on screen. This is the power on screen, and here we are switch on the power by pressing switch 5. So washing machine will be power on, and the highlights will be displayed on the LCD display. Here we are choosing option by pressing switch 4. Here I will be taking wash only. I will be taking wash only mode, and next we have to press long press for changing water level mode. So water level should be selected. I am taking low mode. After that we have to start, so we have to press one long press. Okay, it displays press switch start and stop, press 5 to start, and the timer starts. Here it is taking 16 seconds for wash only. Now press 6 is to pause, and see the fan is stopped, and the buzz timer also stopped, and the cooler also stopped. So we are giving switch 5 to start. 16 seconds will be start. Fan should be on. Here we are taking a 20 megahertz clock, and this is the switch to open mode door, to open the door. And if you open the door, the buzzer will be on, and it displays uh, buzzer. Okay, it will be buzzer sound will be on, and it displays please close text on the LCD display. And after releasing the switch, the buzzer sound stopped, and the fan will be on, and it continues to wash the clothes. I mean, continues to display time, and timer also starts. And now we should wait for 14 more seconds. 7 more seconds.
4 more seconds.
4 more seconds. 2 more seconds.
Last 1 more second.
Last one.
After finishing it,
After the finish of this time,
definitely the buzzer will be on.
the buzzer will be on.
Buzzer sound.
The progress
So the program
displays
will be completed. Remove class
program
and it will be
completed.
continued.
Remove close, and
Start
it
from.
resets
And
and
yes,
starts
this
from
is
the
we
begin.
implemented.
And this is
We
how
learned
we
in the internship
implemented
of Emertxe.
automated washing
Thank you
machine. That's
for
what we learned
us.
in our Emertxe internship program. Thank you.